I am Tarun from Finessefleet. Today we will cover the topic LCM and HCF. Let's go to the lecture number 5, that is LCM and HCF. It is under the course RRB 103 exam preparation program. Now LCM, least common multiple, whereas HCF, highest common factor. Least common multiple, that is LCM. Okay, and the highest common factor, that is HCF. In mathematics, the concepts of least common multiple and highest common factor are fundamental and widely used. LCM is the smallest number, that is a multiple of two or more numbers, whereas HCF is the largest number that divides two or more numbers without leaving a remainder. Understanding LCM and HCF is essential for solving problems related to grouping, sharing and simplifying fractions. Now, what are the difference between LCM and HCF? Already I told the full form of LCM, that is least common multiple, and for HCF, highest common multiple, highest common factor, right. LCM is the smallest multiple common to all the given number, and HCF is the greatest factor common to all given numbers. Now, how do we calculate LCM and HCF? Method of calculation. There are two methods. First of all, the division method. The division method. LCM, how do we calculate LCM by division method? Take two numbers 14 and 8, then the procedure is like that. LCM will be equal to 2 into 2 into 2 into 7, that is equal to 56. How do we calculate HCF? By division method. See, 8 divided by 14, 8 ones are 8, remainder 6, then 8 to be divided by 6, 6 ones are 6, remainder 2. then 6 is divided by 2, remainder 0. So, the HCF of 14 and 8 is equal to 2. This is the HCF. This is the division method to find out the LCM and HCF. I hope it is clear to all. Then the second method. Method number 2. This is factorization. Factorization into prime factors. The two numbers are 8 and 14. We have to find out the LCM by using factorization method, factorization into prime factor method, and HCF using the factorization into prime factors method. Now the process is 8 to be factorized into prime factors, and this will be equal to 2 into 2 into 1, and for similarly for 14 this is will be equal to 2 into 7 into 1. So this is equal to 2 to the power 3, this is equal to 2 into 7. Okay. So therefore the LCM of 8 and 14 equal to 2 to the power 3 into 7, that is 8 into 7 equals to 56. Okay. And for HCF, factorize, first of all factorize 8, 2 into 2 into 2 into 2 into 1, and factorize 14, 2 into 7 into 1. What is the highest common factor in these two numbers? This is the only 2. So HCF of 8 and 14 is 2 only. Okay. This is the second method, factorization into prime factors. So up to this we have discussed about the calculation method of LCM and HCF. There are two methods I have discussed. One is division method and second is factorization into prime factors method. Now I am going to give you a relationship in between HCF and LCM. It is very interesting and useful relation. For two numbers A and B. AB are the two numbers, and the relation will be the HCF of AB and the LCM of AB and their products, that is products of HCF and LCM of AB will be equal to product of the two number, that is A into B AB. Let us take two numbers 8 and 14. We already find out the LCM is equal to 56 and HCF equal to 2. So, here LCM into HCF equals to 56 into 2, that is 112, whereas the product of these two numbers 8 into 14 equals to also 112. So, the relationship is proved. In our previous example, we have seen, what have we seen? We have seen that the LCM of two number 8 and 14 is equal to 56 and HCF of these two number 8 and 14 equal to 2. Therefore, here we calculated the product of LCM and HCF equal to 112 and the product of these two number is also 112. So, the relationship is the HCM and LCM of two numbers equal to the product of these two numbers. What are the applications of LCM and HCF? Understanding LCM and HCF is crucial for solving various mathematical problems and real life applications such as fractions, simplifying fractions using HCF and finding common denominator using LCM. This application we already have seen in our previous lecture, that is lecture number 4, fractions. There we have to find out the common denominator. We used LCM. The another application is timetables and schedules, synchronizing schedules and timetables using LCM. Another application is problem solving, solving word problems involving grouping and sharing. These applications may be clear to you by taking some problems and also practicing some real problems. Understanding the concept of LCM and HCF is crucial for solving various mathematical problems related to divisibility, simplifying fractions and finding common denominators. The methods discussed, including prime factorization and division methods, provide symmetric approaches to finding the LCM and HCF of given numbers. The relationship between LCM and HCF further helps in verifying the correctness of the calculations. These concepts not only have theoretical importance but also find practical applications in everyday problem solving scenario. Let's see how LCM and HCF is applicable in our daily problem. There are two lengths. One is 5 centimeter, another is 12 centimeter. For this case, we have to choose a common scale which can measure these two lengths effectively. In this case, we have to find out the HCF of 5 and 12. What is the HCF of 5 and 12? This is equal to 1. The common highest factor equal to 1. So the scale length will be 1 centimeter, which can effectively measure these two lengths simultaneously without lifting remainders. Okay. This is the application of HCF already discussed. Now take another problem where we can use LCM. See, there are 64 students. Okay, and there are 4 rows. There are 4 rows. One thing to be added, take another example. The HCF and LCM of two numbers are 12 and 144 respectively. If one of the number is 36, the other number is option A 44, option B 48, option C 72, option D 32, which will be the correct option. We already learned that the product of HCF and LCM is equal to the product of the numbers. So here HCF into LCM equals to 12 into 144. Okay, HCF is 12 and LCM is 144, and one number is 36. Let another number be x. So the product of these two numbers equals to 36x. Therefore, we can write 36x equals to 12 into 144. Therefore, x equal to 12 into 144 by 36. Equals to 48. So the answer will be 48. Right? Now, take another example. If the sum of two numbers is 44 and the HCF and LCM of these numbers are 4 and 120 respectively, then the sum of the reciprocals of the numbers is equal to option A 44, 501, option B 501, 44, option C 11, 120, option D 120, 11. Which one is correct option? What is the problem? The sum of the two numbers is 44. Let the numbers are A and B, so A plus B equals to 44. A plus B equal to 44. Because of the sum of two numbers is equal to 44. Then what is given? The HCF and LCM of these numbers are 4 and 120. HCF equals to 4, LCM equals to 120. Given. Then the sum of the reciprocal of the number is equal to. We have to find out reciprocal of A equal to 1 by A and reciprocal of B equal to 1 by B, and the sum of these two reciprocal equals to 1 by A plus 1 by B equals to how much? This is the question. Now we know that HCF into LCM equals to A into B. So here 4 into 120 equals to AB. Okay. Here if we go ahead, then what will we get? See, can I use this part of this board? So 1 by A plus 1 by B equals to okay, then we know that A plus B equal to 44. AB equals to how much? AB equals to 480. So if we simplify this fraction, then we will get 11 by 120. So the correct option is C, 11 by 120. Is there any question to solve, audience? Is there any question?
There might be.
Just a minute. So till now we have discussed in this lecture the definitions of LCM and HCF, the difference between LCM and HCF, and the methods to calculate LCM and HCF. There are two methods, prime factorization method and another method is division method, and the relationship between LCM and HCF and the applications of LCM and HCF. Okay. Fine. Now take another question, interesting question on LCM and HCF. Two trains start from the same station and travel on parallel tracks. Train A returns while train B train A returns to the station every 18 minutes. While train B returns to the station every 24 minutes, right? Then the question is, number 1, how many minutes will it take for both trains to return to the station simultaneously? Question number 2, for the same context, if the trains have been running for 4 hours, how many times will they have returned to the station together? Question number 3, if the length of train A is 180 meters and the length of train B is 240 meters, what is the highest common factor of the lengths of the two trains? It is an excellent question. Now try this. One by one. What are the given data? Two trains start from the station and travel on parallel tracks. Train A returns to the station every 80 minutes, while train B returns to the station every 24 minutes. Okay. How many minutes will it take for both the trains to return to the station simultaneously? So, we have to find out the LCM of 18 and 24. Then we can find out the required times. So, LCM of 18 and 24 is equal to 72. You may ask a common question that how I put the LCM of 18 and 24 is equal to 72 without calculation. I have discussed two types of methods to find out the LCM. One is prime factorization method and another is division method, but here I put the value by mental calculation. It is very interesting how to find out mentally the LCM of two numbers. If you are interested, you may follow up the lectures and certainly you will get the explanation. Then the answer will be how many minutes? 72 minutes. Okay. The answer of question number 1 will be 72 minutes. Next question is, if the trains have been running for 4 hours, how many times will they have returned to the station together? So, to find out the solution of this part of this question, first of all, we have to convert hour into minute. Here, the time is 4 hours. For question number 2, 4 hours equals to 4 into 60, that is 240 minutes. Okay. They have returned to the station together. For single time, it will require 72 minutes. Within 240 minutes, how many times? 240 divided by 72. So, the whole number is 3. The whole number is 3. The answer will be 3. Okay. Therefore, answer of this part of this question will be 3 times. Last part of this question is question number 3. If the length of the train A is 180 meters and the length of train B is 240 meters, what is the highest common factor of the length of the two trains? So, we can usually find out this, the answer HCF by any of the method, prime factorization method or division method. I am using the division method and finding out the HCF of these two numbers. The HCF of these two numbers is 60. So, the answer is 60 of this part of this question. So, the question is very interesting and it has 3 parts, that is 3-part questions. I already solved each of the part one by one and I hope that you understand the whole process. So, in today's class, we have discussed about the LCM and HCF and the full form of LCM and HCF, as well as the difference between LCM and HCF, the method to calculation of LCM and HCF, and as well as the relationship between LCM and HCF and the applications of LCM and HCF in our daily life by explaining some problems. Thank you.